Everybody, so let us start our lecture. This morning we started object-oriented programming in our last session, and today we will continue from there. So, for instance, we are discussing class and object. Okay, so a class is a general name of a group of similar instances. Okay, for instance, that I call a few volunteers here, okay, to bring some pencils, one pencil over here. Okay, so you see that, please raise your pencil. All of these are called pencil, right? Is it a pencil? Yes, sir. Okay, is it a pencil? Is it a pencil? Claim to be pencil, right? But you see that in terms of color, size, and maybe diameter or brand, quality or price, these are different, right? They're different, right? But these have maybe some common characteristics, features, right? This is why these are called pencil, not a pen, or not a computer, right? Okay. So let us figure out what are the characteristics, common characteristics these items have, so that we are claiming this as pencil, pen, or a computer. Okay, so I want to start with a new package with class. Yeah, tell me the characteristics of this. Why do this as a pencil? Or what are the characteristics of this? Common characteristics of these objects. Okay. Okay, so let us create a package name, and in this package, see that I want to develop a class named pencil. Okay, my class is pencil. Okay. So a class starts with a class keyword, and then this public in in Java. A file is set by this name pencil and public file, public class. Okay. So what are the characteristics this item have? Okay. Okay. So what is the type of this? Can write. This is a function, right? Can write. This is a function, right? Okay, so let me say public void can write. Okay, this pencil can write. Okay, let us put some output. You can look over there on the screen. Okay, this pencil can write. Okay, this is my simple text. So what are this is an action. This is can write is an action that this item can do, right? Or this item can be used to do. Okay, what are the other features that these objects have? Can write. I had mentioned it. What is that? Okay, then that I can say Boolean has eraser. eraser. If it has an eraser, then it will say either yes or no, right? Some of these have erasers or some of these no, right? But in order to be a pencil, we should have these characteristics. Whether it is for a pen, we do not expect that it will have an eraser, right? Okay. What else? Okay. So it should be a model, right? A brand or model. What is the data type for a model? String, right? String, like model, company, for instance, string model, right? And if it is a cheaper item, then or a like nominal item, that it will not have an ID or a serial number, right? But if it is a costly item, right? large item, that we expect that it should have a serial number, right? For a pencil, we do not expect that it will have a serial number, right? Not a serial number, right? But we can expect that, for instance, for any model, we may have a serial number. For instance, int. For pencil, we know that, but we can serialize them 1, 2, 3, 4, 5, 6, like this, right? Okay. Yes, that what will be the type, data type of type? Yes, string type, right? Okay. So we got serial number integer type, and we got model string type, and we got type, that is string type, and we got another attribute has eraser, that is a boolean type, either yes or no, right? Okay. So all pencils have this characteristics common, right? So we want to develop a pencil class. So by hearing the term pencil, what do we imagine? Imagine an item or an object that has some or all of these characteristics, features, right? Okay, and most importantly, it can be used to write something, right? So this feature is action type. So we call this is method. Okay, this is method. Can write is a method, and these are variables. These are used to, for instance, for pencil to pencil, serial number should be different, model should be different, type should be different, as eraser should be different, right? We can say another type, eraser kind. Some erasers have large erasers, small erasers, other type. So starting from here, we can enlarge this list of attributes, right? We can also enlarge the list of functions that pencils can do or can be used. So in general, so we are declaring a type or a data type or a class that we will call pencil. Okay. So this is the concept of a class. And so far, we have only type, okay, a pencil. We just declared a type that is called pencil. We do not have any instance of this type yet, right? Now let us do where we can declare an instance of this. We need another method, mainly the main method, where we will create an instance of this. Okay, remember that we will be creating a real pencil. We will be creating a virtual or imaginary pencil. How can we create an imaginary pencil? We need another main method. So we need another class maybe. For instance, we can say this class pencil main. Okay, main class. So notice that in my previous class, I did not have main method. In my pencil class, I did not have main method. I just declared my type class over here. Now I will use this class where inside another class, maybe my main class, where I have main method. Inside my main method, I will use this pencil type, okay, in order to create instance pencil instance. How can I say? I can say maybe say p1 equal to, we need new operator. This is the format. This is the syntax, okay? And then what next we need? We must need this. We need to use pencil. This is called pencil constructor. This is the method, okay? We will learn today what is a constructor, okay? This is, by this way we have created P1 as a pencil type. What are the features this P1 has? What are the features I have declared for my pencil type? For instance, serial number, model, type, has eraser, can write. My pencil item P1 should have these characteristics. How do I know that my pencil has these characteristics? If I type on P1, then dot, then you will see that it will pop up a list of first one. You see that, give attention. One more minute. Stay here. Okay. So first one, it says has eraser, and then after colon, can you see that? After colon, it has boolean, and then there's a dash sign and pencil. Let us understand what does this mean. This means that this has eraser is a method, is a feature, a variable, okay, that is type boolean, okay, and defined in pencil class. Okay, the next one, model, this is a variable and that type is string and that is defined in pencil class. Next one is serial number, that type is integer and that is defined in pencil class. And the next one is type, that type is string and that is defined in pencil class. And the last one, can write, this is the method. How do I know that this is the method? It has a parenthesis, right? After name. Wherever you see a parenthesis after a name, then that will be a method or a function, okay, that or an action, and that return type is void and it is defined in pencil class. Okay, after that we see that there are other methods, equals, that get class, has code, notify. These are defined in class. Object class is a built-in class. Compiler has this class. We will be able to enjoy its features. Okay, right now we are not focusing on object, but we are focusing on the pencil class. When you learn inheritance, then you will understand this object class or something. Okay, but for now you understand what is meant by has eraser, boolean, pencil. Let us double check. Okay, this has eraser, it has a little bit triangle on the left side. That means it is a variable or an attribute, and that type is boolean. Okay, and then pencil is defined in the pencil class. So now for a pencil object, we just created a P1 object that is empty, that has nothing. We have not assigned what are the attributes of pencil. Has eraser, model, serial number, type, right? These are the attributes, but we have not defined this attribute. For instance, let me assign his pencil is P1, okay? So what is the has eraser? So if let's say P1 dot has eraser, okay? Does it have an eraser or not? Okay, so let us say false. Then if it's no, then let us say false. Okay, let's consider that it's false. If then I will say yes. Okay, and then P1 dot, tell me a model. Yes, brand or model. Dixon. Equal to? Dixon. Okay, Dixon, whenever you say model, you see that P1 dot model, that is showing me string type, right? So I must provide a string value. So how do I provide a string value? Okay, equal to within double quote, how to Dixon. DICXON. Okay. So then P dot has serial, okay, serial number. Maybe I want to say 1. Okay. Let us think 1. Okay. Okay, and then P1 dot type equal to, since type is string type, so I have to pay HB, right? Okay, and then P1 dot, okay, can write. So can write, we are calling this pencil. So for instance, we are calling this can write method. So now let us run it. If we run it, we will get only some output for this can write method, not for this, okay? Because let us run it and what we see here. This pencil can write. Okay, where this coming from? This coming from? This text is coming from can write method. Okay. Similarly, if I okay, now for instance one thing. For instance, if I want to print P1 like this way, what do you think that what we will get our output? So for instance, let me, before I discuss this, let me do that. If I have an integer variable x equal to, for instance, 10, and if I print sys out, then x, then what will be printed? 10, right? But if I print P1, it is not easy. It will show me something garbage. So my x is 10, but my P is, it is showing me class package dot pencil at the rate something. It means that P1 is an object that is defined within pencil, that is pencil, and that is defined in the pencil package. Okay, so class package, this is the package name, and within this package it has a class, and after at the rate it is showing me a memory location, address of a memory. Okay. It is a compound object. It is located somewhere memory, somewhere in this world, in the universe, right? For this universe, for instance, it has a location in terms of latitude and longitude. Okay, so you are done. Thank you so much. Yes, you can go. So far, everybody understand this? What we have done so far, we created a pencil class, and then by using that pencil class, we just created an object, pencil instance. Okay, now, okay, if I want to create more pencil object, as many objects, since these are virtual objects, I don't need to use any money to create this pencil. So it is easy that I can create more pencil, but only one thing I need to be careful. I cannot give same name. Whatever, if there is another pencil object with same name, I have to give a different name. That's it. For instance, P2. Then I'm fine. As long as I give a different name, then I'm. So for instance, P2, P3, P4, P5, P6, P7. So as many pencils instance I need, I can. Okay. So now remember that only I have assigned values only for P1 pencil, first pencil. Okay. Not other pencil. I have not defined attributes or values for other pencils. So we will use similar fashion. That's similar way we will use to define other features for the other pencil, right? For instance, let me copy this and let me put this code here. So let me say, if I say again P1 has eraser false or true, then it will overwrite. Sorry, it will override the previous one. But I want to assign for P2. Okay, so let me do it P2. Let me do it P2, 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 and then let me come your pencil. Let me say his pencil is P2. So has it an eraser? Yes. So let us say yes. Since it's Boolean, sorry, not yes, means true, right? Okay. Then what is the model name? Okay, Dixon, right? Also Dixon. And then what is serial number? Let me say, right, okay. And what is type? Is B2, okay. and then can write. Let us call can write same can write method. Okay, and now let us go done. Thank you. Okay, and let us set up the features for P3 pencil. P3, 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 P3. Let me tell that as an eraser. True. Okay. Now what is the model name? So B is model name is BIC. Okay. Serial number. What serial number do you like? 3 is likes. What is type? Okay, so unknown. You say like ASB is common is ASB. Pencil, right? Okay, and then can write. Okay. Now let us do similar thing. Thank you so much, and thank you for his pencil. So let us make it P4. P4. I'm doing hurry. Okay. So never mind. So what is has eraser or not? So yes, has eraser. Yes. Okay. What is the model name? Sorry. WRIT. Okay. What is the serial number you want? Okay, 4 or anything you like. Okay, then fine. What is type? Is B. And let us call P you can write. Okay. And let us do for the last one. Thank you so much. P5. For P5. Okay, has is that? Yes. Okay. So this what is model? ZARO. Okay. Okay. Z or J? This one? ZEBRA. Okay. Let us think that is okay. Serial number. What serial number is? 0. Yeah. Okay. 0. What is type? M301. Okay, and then let us call this. Thank you so much. So now we understand how do we declare a type, a class. Think that like a class, so we just created a type, our own type. This type is a compound data type. Okay, and this is different from a natural type, or is called primitive data type. For instance, this is different. For integer type x, we can hold only integer value, but we have seen here for a class type we can contain multiple data, right? So this is the concept of creating or developing a class and then creating instances of that class. So anyone has any questions so far? Now if we run this program, okay, if we run this program, then it will show us only this pencil can run, and then for instance can write. Okay, one more thing, maybe if I want to show you this. For instance, if I want to do this, okay, give attention please what I'm typing in, give attention here. So I want to print P1, P2, P3, P4, P5. My output, if I want to print only this. Okay, since I want to see output only up to this, let me put something like a border line. So I want to see my output after this borderline. We'll consider output from this. So let us run this. Okay, that is our output. After this borderline, we are expecting this output. We want to understand this output. So all of this, what we printed, the instances, object directly. Okay, so it is showing me the P1 object equal to is located in class package dot pencil at the rate. This is the memory location. That means P1 object has taken memory place on this place. Residing on memory, this is RAM location. Okay, we do not need to figure out, search for where it is exactly. Take your computer in order to understand where it is located. We don't need to, just to realize that is located on this memory location. You see that P2 is located in another memory, and P3 object is located in another location, and P4 object is located another location, and P5 is in another memory location. Okay, but this output, actually this shows the actual memory location where this object resides, take place. But probably we will not use this way. In order to get our expected output, for instance, this kind of output for P4, P5 has this eraser type true, model type this. In order to get our meaningful output, we need to do something else. Okay, that is called, actually we need to override a method, toString method. Okay, so if we click on P1 dot and see that go, let us go all the way down, and at one place we will see toString. Okay, so toString is a method that is in object class. Object class is a built-in class. For now, just remember that. But in order to use this, so this method, it returns a string type value. Okay, and in order to use this, in order to use our display our object in meaningful way, we need to override. That means we need to write this method according to our need. So the description says toString method returns a string representation of the object. In general, toString method returns a string that textually represents the object. You can do not need to memorize, but let us see what does this mean. Yes, so let us copy this. So where do I need to rewrite this? We need to rewrite this in my pencil class. So let us copy this. Just I want to copy here to see what does this mean. Just, and we need to override toString method. It depends, it varies, the syntax varies language to language a little bit. But for Java, we start with at the rate character, then O is in uppercase, DERRITE. You will not understand override maybe at this point a lot, but for now, memorize this. Okay, override. So public string. Why I want to print string? Because just a minute ago we saw that the toString method returns a string type. Then we have to write exactly toString like this way in Java. Okay, and then it's showing me an error, right? Because I have a return type string, I need to put a return statement. Return what I want to return. For instance, return maybe what are the values we have? Type model plus this dot model plus, let us put a sprint space, and this dot maybe type. Okay, for instance, let us only print this. I will go through, I will come back later. Okay, if you do not understand this, don't worry for now. Now let us run this. Let us see if we get something different output or not. Oh, we got something, right? Here I got, this is my model name of my pencil P1, and this is what next item I wanted to display, model plus type, right? So this one is model of first pencil and type of first pencil. This one is the model of second pencil and model type. See that? So in order to get a meaningful output of my object, we need to override the toString method. Override means rewrite. Okay. Rewrite where is toString method is originally located. Originally, this toString method is declared within object class. That is a great parent class. That is built-in class my program. And just we are going to rewrite this so that we can get our expected result. The format of toString method is that it returns string representation of the object, and then in general the toString method returns a string that textually represents this object. So in order to do this, we need to use this operator. Okay, if we do not give this, let us see what happens. If we do not give this, let us see what happens. Okay. For this case, it is showing okay for now, but if we use implement inheritance, that is another property of object-oriented programming, it may give a different result. Okay, so for now, it's okay that if you do not use this or that is fine. For instance, now for now we have displayed only model, and let us put serial number. What is my variable? Serial number plus model plus something. Let me see if I get. Okay. Now you see that put for serial number on the top, serial number. What is the next one I wanted to? Model type. And by this way, I can add other features, but the whole thing, it will be a string. Since the toString method returns a string type, so we need to all of this. So far, anyone has any question? Everybody understand? This is the foundation of object-oriented programming. If you understand this, then you understand maybe 1/4 of object-oriented programming language. So far, whatever I discussed in this lecture, if you understand this, then you understand 1/4 of object-oriented programming principles. Few more features that you will learn some in this lecture, in this course, but not all in this course. Any questions so far? Yes. Okay, yes, C++ is different. That's a good question I wanted to tell. C++, in order to declare a class in C++, we need to write in Java and C# and Okay, we are fine. We start with so now maybe for now I don't need, I want to concise my memory location space so that I can put all in one line, one space. In C++, a class ends with a semicolon. C++, this will end with a semicolon. One major difference. C++ class start with ends with semicolon, okay? And there are some other difference. Let me discuss this in next lecture. Has other question? Any other question? I like everybody understand this, okay? If you do not understand this, then you will not be able to understand the remaining lectures. This topic. I want to make sure that everybody understands this. Anyone has any question, do not feel shy. I will repeat it again and again until you understand. Understand? Okay? Yes, I'm asking you. Yeah. Okay, thank you. So whatever we define, whatever we have done so far, we created a class or a type. This type is not a primitive data type. It is a compound data type. We call this type as a class. A class starts with a class keyword and followed by a class name, and within second bracket or brace, and then it ends within bracket, and in C# it ends, in C++ it ends with a semicolon as well as. And within class we will provide attributes, some variables. A class contains some variables and functions in order to access those variables. So what is the purpose of this function? When a class contains some function, that is called method. So the purpose of method is to access these variables. Okay, when we will create an individual object, then for each individual object we will be able to provide values. This is how an object-oriented programming or program starts. How many minutes do you have? Minutes. Okay, so let me go in these 4 minutes. Let me go to 6. For the return to string method. This return method is returning, okay, returning some as a string, this string. To actually this two string method is not required to call directly, explicitly. Implicitly it is called. This method, for instance, let me review it. If I do not have this, when I did not have this, so what was my output over here? Something weird, right? Something meaningless, right? But I just override the toString method, but I do not need to call this method explicitly. But if once I have this, then if I run this program again, same program will give me a meaningful output. The toString method is not required to call directly. Yeah? You understand? So, in our next lecture, we want to go through some of these slides. Let us see on 1 minute whatever we so far what we have covered. So we covered how to create a class. A class name can be any name we can give. Okay. So then Class contains some variables and some methods. Okay. In C++, it ends with semicolon, and all classes start with a class keyword, all in small letter. So by declaring a class, what we are doing, we are creating a new data type. It is a complex data type. Okay. By using that data type, we will be able to create some instances of data type, virtual instances or imaginary instances. Okay. And I think that so far we have covered until this. Okay. Now, next lecture, I will go through these slides as much as I can go through, and then maybe another thing, important thing, we need to discuss constructor. We will start from constructor in our next lecture. Anyone has any question? So please practice. Everybody, please practice this program. Okay. I will put it on repeat.